Okay, so I ran my scripts to basically combine what you have, your grades. Specifically, like over here, I've got all the stuff from Canvas, which for obvious FERPA reasons, I can't open up because that's got everybody's grades and names and stuff in it. Same with Runestone. So I've got all the grade books from these two systems that don't really talk to each other, but they output their both what they have as CSVs files. So what I do is, and this is an example of how grading can kind of, even if you don't go into programming, can make your life easier because you've got two disparate data sets, two disparate spreadsheets. And what I've got here is this file, which I just called grade combo, which in 30 lines and a bit of trial and error does a lot of, basically does the hard part of matching up combining the two grade books. So the big thing is I can't just copy paste them because students come in and out of the class. Sometimes students make duplicate accounts. Sometimes students forget to sign up, or they, it's not as easy to copy and paste because I can't just copy and paste a column. I have to copy paste. I would have to copy paste one at a time. So I wrote a script to do this automatically for me and put it out in a new file. So the first thing this does, so let me go ahead and eventually with it by maybe week 10, you'll be able to probably do something about this. Like this. So the first thing I did is I imported a built-in library called CSV. CSV stands for comma separated values. This is basically what you would want, what you get when you kind of export data in a text format as opposed to an Excel file, right? Something that is readable, that has the source code completely readable by humans. Now, 2 and 3 here are dictionaries, which we'll go into in detail much later. But what they do essentially is that they allow me to make arbitrary key value pairings. Basically, I get to make up whatever. They don't have indexes, they have keys, and keys are like indexes in the sense that I can just make up whatever I want for them. Okay, so the hash and the email. Okay, so here what I do is I open up the Runestone file, okay, and I say I'm going to read it. And then I basically turn it into everything into a list. So basically I've got the first row and the second row are basically the assignment name and then the, how many points they're worth, okay? And then I say from the next row to the end, for each row to the end, what I'm gonna do is it's like, it's a table. I say, hey, what does the width do? That later, but that's basically part of what we use for opening files. That's not totally necessary, but it's just something that I did so that I could. It's just something I did. Don't worry about it too much because we don't really need to use it. But just know that's part of what I'm doing to open files. So what I did is that basically I look for your first name. I get your last name. I get the last name that the person was signed up with, add a comma and a space, and then do a first name. And what I do is I capitalize and then strip out any additional or any leading or preceding white space. So what this does is basically it puts it into the format I want. So it helps deal with any kind of weird capitalization. And then I get your email and say, hey, if I give you this email, give me this name back. And then I say, if I give you this name, give me all of the grades associated with you. That's what the hash is. I don't know why I named it like that. And then what I do is I do the opposite reading, which is writing. So I create a writer. I say I'm going to create a new file called output. And then for every line in the Canvas file, your Canvas file has all your information in it. So what I do is I look at everybody and I say, hey, give me your name. Now over here, what I was doing was putting your name in the same format as Canvas does, okay? as Canvas has. That's what I'm doing over here. So what I do is I get your name and then I get your email as kind of a secondary effort. And so what I do is I say, hey, if I saw your name, awesome, I found your grades. So I say, awesome, here's the grades for that student. If I see your email, I say, awesome, here's the grade for that student. Otherwise, I do some hackery to remove your middle name or initial if it's in there, and I try that. Otherwise, I just move on. So places where this could fail, by the way, is if you've got two. So what I'm saying is that basically there's a couple of places where this could fail. One is if there's a different spelling for your name, if your email address and your name were misspelled, or, and this is the most likely outcome, you accidentally made two accounts. So if you have a bunch of zeros for the runestone stuff, just let me know. Send me an email. I'll try to figure out why that is. But this is part of the reason I said to sign up with stuff, because it enables me to upload it much easier. I'll do another upload very shortly once the quiz 2 grades are updated or are all turned in. So, but otherwise, yeah, this took me about, I don't know, like an hour to write, and it somewhere between half an hour and an hour to write, and not like in a super focused manner, like having other stuff going on in the background doing it. And it saved me countless hours of work, because it is not possible to just simply take everything and put every grade in one by one. It would take literal days to do that, because I have a lot of students, and then I would have to double check to make sure that every grade got into every position. So, but that's kind of just, just how this has helped me. So let's take a look at where we are. So we're module 6 right now. I'll be publishing quiz 3 soon, and I'll tell you what that's about once I go through it and make sure there aren't any dumb artifacts from last semester. With regards to with quiz 2, there is some questions like the drag and drop one that have more than one valid answer, and that was an accident. So if that's the case, don't worry about it. As long as your code, as long as what you have works, I'll give you credit for it. Okay. Yes, once you get to, if you haven't done the exercises that have been run for Runestone, next time you do them, next time I run the grader and then do the merge operation, it will work out. I had meant to do this last night, but somehow again my internet was down. If I had a nickel for every time my internet's gone down for a day, I'd have like 2 nickels, which isn't much, but it's weird because it happened twice. So I try to run this basically. I'll try to run this this merger basically after every major quiz. So, but this is just simply importing your grades into Runestone and categorizing them appropriately. Most of the, again, with your assignments, it's 5% of the grade over here, and I'll probably drop a few of these, the lowest. Same thing with the in-class exercises. They're just easy ways to make an extra 5% on your grade. As far as quizzes, the lowest quiz will be dropped. And at least one of the, and depending on how these work, how grading works for these, one or two of the assignment of the lab will be dropped. So the upcoming lab, which I'll have to adjust the due date for, is which will be introduced in lab 6. This Friday / Monday. Is Mario Cash and Credit. So basically, you have 2 versions of Mario where you make a pyramid from level 1-1, and part of this is teaching you input validation. So basically, refusing answers when the answers aren't good. Like You want a number between 2 and 8, but if you enter 9,000, I want you to reject that answer. And then doing one, so it's 2 exercises, one of these 2, and then either doing a change, basically how many coins does that give you kind of change operation, or how many coins do you get as change program, or credit card validation, which will able to, given a credit card, tell me whether or not it's a real credit card. Because credit card numbers are, they have an internal consistency. Okay, after that, we'll be getting into the hurricane tracker, which will probably be kind of which looks super intimidating, but is actually not that difficult. Once you get over the whole, oh gosh, this looks so scary kind of deal, and you understand how to read files, this program actually is actually one of the more favorite ones of mine, because it kind of combines everything together. The biggest one for this one is people misusing longitude and latitude. That's the biggest thing, confusing what longitude and latitude are. So just making sure your dimensions are set up correctly. But overall, we'll have spring break soon, and when we get back, we'll start on the more difficult exercises before talking about our final project. Okay, so with that said, what we're going to be foregoing doing some exercises from Runestone, and instead what we're going to be doing for the next couple days is working on exercises that I used to give out as homework, right, as extra practice. The first of these can be found on Canvas by going to our modules again and just scrolling down. And let's see, do I have to? Yeah, I'm gonna go ahead and activate both of them. The loops. So in class exercises, loops. So this is done similarly to the way we did the date validation one last class. So let's go ahead and download it and look at it. So these are primarily for loop exercises, because I know some people still need exercise on for loops. So we're going to go through these and we are going to do them. I like these because there is a number of ways to do each of these. Okay, there's a lot of ways to do each of these. And while I favor some approaches more than others, if it gives you the right answer, it gives you the right answer. So first one is number of vowels, which given a string gives me the number of vowels in that string. Number of even digits. So, and then the 3-digit Armstrong number, and then the Riddler problem. Okay, so this is something we used to do for class. So the big thing here is that we are going to be dealing with return statements, right? So how many of you do not know how to handle return statements yet? Return statement, drawing a blank for people? Okay, cool. Plenty of shy hands going on. Okay, which means that there's more of you who do not want to raise your hand out of fear of embarrassment. So, right? So let's go ahead and kind of give a brief demo of what those are. They are covered in our textbook, but we may not have gotten to that point yet. That's fine. So let me go ahead and save this as desktop. In class loops, PY. Okay. So what we've got here is, if I've got a function like add, right? Again, a really dumb function where we're just going to take in 2 numbers, X and Y. What we've been doing so far is we've been basically printing out the sum, right? So if I call add 5 and 6, and I run it, it's going to print out 11. But if I create this, this doesn't really necessarily do much for me. I can't store the answer anywhere. The answer got output. Print means give that to the user, or give that information to the user's eyes. It doesn't give it to me to use in any significant way, shape, or form, right? I can't say, hey, give me the sum of 5 and 6 and 3 and 4. I can't do this, right? I can't add 11 and 7 together, because these expressions, all they do is print something. They don't give me any actual data. Does that make sense? They aren't giving me anything to use. So all functions return something. That means it gives something back to the program when it evaluates. By default, if you don't have anything, your program looks like this, or your function looks like this, return none, which means we aren't returning anything. And so when I try to do, so this prints out and evaluates to none. This prints out and evaluates to none, which means that I got, and now I see, hey, unsupported operand types for, you can't add nones together. It's void, it's nothing, it's nothingness. You can't add nothingness together. Okay, can't do anything with nothingness. And, you know, I can't add them together, and I can't even do this to them, right? I can't add them together with my same function like that. Again, nothingness. So what we do is, rather than printing something out, if we want the program to be able to use any answer or data internally, we use return. And now it doesn't seem to do anything because we aren't printing anything out in this case, but that's fine. So let me break it out into a few separate chunks, shall I? Print. Now I can print out the sum of those things. 11, 7, and 17. Right? So what this does is that this evaluated, and rather than giving me back none, it gave me back 11. Rather than giving me back none, it gave me back x plus y, 3 plus 4, which gave me 7. So when you return something, you get something back. And this is the way a lot of our functions have been working, by the way. Whenever I say something like, whenever I use a built-in function like len of word, that doesn't print out the value of word. It doesn't print out how long word is, right? Didn't print anything out. It returned a value. So, and by having that value returned to us, that is how we're able to use it in the print statement, like that. So printing out functions, so returning things allows us to work with them in other parts of the program. There is just there's one important rule to understanding how how the return statement works, by the way. Okay. Okay. Adding 5, 6, adding 3, 4, adding 5, 6, adding 3, 4, adding 11, 7. Notice that we never printed out done with add. Okay. Notice that never gets printed out. A return is also if you return something, that means you're done with the function, right? So once you hit a return, nothing can happen. Make sense? You do the return as the last statement you want to do, or to stop in the middle of doing something, which is less common, but also very useful. Like if you want to stop in the middle of a loop because you found your answer. Okay, so a very common mistake, and one that lets me know that you're not really, haven't really understood the way returns works, is when you do have code like this, that's after the print, like code that will never run because of that. We can, and return only really, you can, the return statement can only get called once. In most languages, you can only return one thing. In Python, that's true. You can only ever return one value. So you could return only one number or something like that. Except Python allows you to cheat, as we'll see later on, and you can act like, you can make it act like it wants to return two numbers. Technically, what it's going to do is that, as we'll see later on, it returns one number, sorry, it returns one group of numbers, but it will automatically unpack it, which is pretty cool. So Python, you technically can return two things, although even though that's technically one thing that's being returned. All right. So now that that's all set up, number of vowels, write a function which, given a string, returns the total number of vowels that were in that string. That means you need to feed the function you write a string as a parameter and return an integer. So let's set up that problem first, and then we'll leave it to you to implement the rest of it, right? So here we're just counting the number of the vowels, which means that we're using the accumulator pattern, right? If we're counting the number of times something occurs, right? So here we go. Then that's a good use for the accumulator. So let's see, def num vowels. And I'll pass in what I want, what I want as word, because that just takes 4 letters. And what we're going to need, since it's the accumulator pattern, is that we'll need to count how often it occurs. So we'll do count is equal to 0. And this is the part, right? And then we'll put our code in here. And this is the part we just learned. Once we're done with it, we'll return the count, right? That's what we'll do. We set the count equal to 0. We count how many vowels there are in word. And then when it's done, we return the count. So what should I expect? Let me go ahead and comment these out. If I do, and the fun thing about this is that this technically will run, although it will give me the wrong answers. Num vowels, hello, will give me, that should give me 2 back, right? Assuming like, why isn't that lined up? Because I didn't copy that correctly. Hello, so this should give me 4, this should give me 2, and this should give me 3 vowels. Ether. As in luminiferous ether, which is the precursor to the general theory, which was the debunked precursor to the general theory of relativity. Okay, so when we run this, we should get 2 and 3 when we are done. Right now, of course, we will get 0 and 0 because we set the count equal to 0 and we return the count, which is 0. So we now actually have to physically count that. So I will give you about 2 minutes to do, let's say 3 minutes to do this, and then I will give you the answer, and we can go over multiple ways to do this one. Okay. So, yeah. And if you're not sure where to start, basically look at every letter and ask yourself, is it a vowel? If it is a vowel, increment your count. Otherwise, just move on. Okay. So people like to a little more time to work on this one, or give you another minute or two. Okay. So for this one, what we're going to do, there's a bunch of ways to do this. The most direct way, but also the most is not the most necessarily fun way, which is to do for letter in word. So for each letter in the word, if letter equals A or letter equals E, U, O, I. Right? If the letter is A or the letter is E or the letter is I or the letter is O or the letter is U, then in that case, I will say count is equal to count plus 1. Yes, and that in chat was the other way of doing it. So this way is direct because it does exactly what you want. If the letter is A or E or I or O or U. Another thing I might want to do, though, just to make sure, because we've also got, what if the person has used capitals? First off, let me run it to kind of ensure that it works, right? We see that we get 2, 3, which is our expected answer. What if they use capitals, though? Like over here. Run it, and we get 2, 2, because capital A and lowercase a are different characters. It's not, this is one of those things where if somebody's a jerk, they'll take off a lot of points. I'm not a jerk. If this was the kind of thing and I wanted you to catch it, I'd say, be sure to account for uppercase and lowercase letters in the question prompt. And then I'd take off like a point or two, depending on the amount that it was worth. Because the way we can do this is that we can just turn them all to lower. We can either add more cases like capital A, E, I, or U, which just makes this awful looking, but it's practical for the other solution set that we'll do. Or alternatively, we can say word is equal to word dot lower, turn everything to lowercase, create a new string that is lowercase, store it in the variable called word, and do that. It's important to know that if I do test 2 is equal to, it's important to note and this rule for your that helps preserve your sanity. I say preserve it because it's important that your sanity is preserved. You'll note that test 2, I say word.lower is equal to word, but it doesn't, but it did not change. It did not change this. It did not change the word that was stored. Now, why is that? Because we stored ether in this box called test 2. And then when we passed it into num vowels, we copied what was in here over into word, which is where we find, in other words, that's where we find word. And then what we did is said, make a new word from the old word, make it lowercase, and store it in this other box, right? Let me go ahead and just draw out what's happening because this is a very important point. It's useful to think of your variables as boxes. So we had S2, and we also have word. Okay, inside of this we have ether. Technically, we have a memory location to ether, but that's okay, right? The example still stands. When we go over to when we do this over here, we copy what's in here into here. Okay. So now when we do word.word to .lower, what we're doing is that we are changing this in here. We make a new string and we change it in there, and we change what's in the word box. That doesn't change what's in the test 2 box. And again, you will be turning this in just like you did for Thursday. And again, technically what we're doing is that we are copying memory locations. Where we find word. And then we create a new word, which is maybe located at location 50, and that gets copied into there, right? That's technically what happens. But that's just another level of extraction that Python helps you remove. But the point being is that, my God, what if we had to keep track? What if the values did change, right? What if those changes were preserved? If I named a variable something else, right? And I keep track of the changes. Fortunately, there's only one data type that's subject to that, and that is lists. So just keep that in mind. Lists are really and dictionaries are those kind of collection ones are the only ones that really you have to be careful with, but otherwise it's fine. So another way we can do this a bit easier, by the way, is that we could have we can create a variable called vowels. Okay, we call it AE, and we just put in the vowels over here. Okay, and then what we can do very easily is say we could do another nested for loop for val in vowels for each letter for vowels, val and vowels, if letter equal vowel. So if the letter is equal to the vowel, it may be easier for you if I do this. If letter is equal to that particular vowel, increment the count. But there's an even more efficient and clean way to do that, which doesn't rely on a nested for loop, which is which is just simply doing if letter in vowels. And it asks, hey, can I find this substring, which is the single letter, inside of here? Is letter in this word? Is letter in this string? So, and the answer is yes, it is. So, and then again, having capitals doesn't necessarily become much big of a deal because you can just type like that. But that's, okay. Moving on to the next problem. This one has, those were, the ways we did this were refinements of a single version, but this one has drastically different ways of approaching the problem. Okay. So write a function which, given an int, returns the number of digits in that int. For example, if the function is passed the number 254, you should give me 2 because 2 of the digits, 2 and 4, are even. So if I passed you 100, you'll also give me 2 because 0 is even and 0 is even. Or if I give you 1,544, you'll give me 2 because 4 and 4 are even. So there's two ways to go about doing that. Why do I add 1 to count? Because if I didn't, count would never change. It would always be, we need it, if we count another, so it's essentially like going 1, 2, 3, 4. Without that, we'd be going 0, 0, 0. Okay. So, the number of even digits, again, so there, I say here you will need to use modulo and division to solve the problem, which is the way I will do it, and it's the way I prefer. But there's also another way you can go about it, right? Which is turning this into a string, and then checking to see if each thing is an even, just like you did for last problem. So def num even digits x. And again, say count is equal to 0, return count. Okay, so there's again, you'll want to, so there's, as I was saying, there's two ways to go through this. The first is to take x and convert it into a string so that you can manipulate it. One of the common problems I see is students trying to do this for a digit x. That doesn't work. You can't iterate over a integer. The other way you can do this is with a while loop and using a combination of modulo and using modulo division and division. So specifically integer division. You can tell if something's divisible by 2, right? I can tell if a digit is divisible by 2 by taking that digit and modding by 2. If I get 0, it's even, right? Right, so if a number is evenly divisible by 2, I'll get 0 as the remainder. Okay, the number is evenly divisible by 2, I get 0 as the remainder. That's what this is saying. I'm saying, hey, what's the remainder of this number when I divide by 2? And if my answer is 0, then great, it's an even number. So that's the key, that's step 1. Step 2 is the fact that basically that if I take any number, say like say like if I say 7,558 and I do integer division by 10 on it, then that essentially throws away the last digit. That gives me 755. So I'll show you a couple of different ways to do this, but go ahead and try it on your own for about 5 minutes. Because this one's nice. I like this one. Because there are two different diametrically opposed ways to do this.
Any way to get this variable print up after?
can't get it to print after doing a return. A return stops it. What you want to do is print that after it's called.
Yeah, so I return it normally
So
print it after I.
surround that with the print.
Okay.
That's the way to do it.
I'm asking because in the next lab, I started working with the credit one, and I use a def function
Mhm.
to tell me what it's valid,
Mhm.
and then I have the valid, and then I have to use it outside the function. I don't know.
So you always need to return the value. If you need to, you can always have a separate function. Like if you have a separate function, like saying whether or not it's valid, you can do that as a separate function. Checking if valid is fun. So here, right? You don't need to print out this. Okay, you just need this.
Yeah.
We get this back out and we print it there. With regards to the other problem, when you're doing input validation, that one uses a while loop, and you just basically keep asking if you're talking about the lab.
Oh, I return valid in the loop function, and I can do it down here. And then if valid is true, and then here it says in the function.
If valid is true, oh, scroll up. What's the name of the function?
Clue.
Oh, I don't think. Oh, okay, there it is. You may have returned it, but you didn't store it anywhere. This variable doesn't exist except inside of there. It doesn't exist except inside of this function. So now that you've called it, you get back your true or false. And then you can store it in a function in either a variable called valid or answer, like this, just to give it a different name. So, and then in which case over here you would say,
If the answer is true.
right, exactly, because the valid only exists. So variables only exist within the scope they're created in. So if they're created within a function, they only exist for the duration of that function. All right. So with counting these digits, there's a couple ways to go about this. So first is count is equal to 0. Not sure why I had M there, probably because I was in the middle of typing. So first and probably the most straightforward way, and the way that most students try to tackle this one, is by saying let number is equal to, convert this into a string. Double equals for checking equality. You only ask that for true false questions. Single equals is for assigning. And we aren't checking any equality signs yet. So we turn this in, we turn this number into a string of text. Next, what we do is that we you feeling okay?
I jumped on the water.
Oh, that sucks. Just got us worried there. All right, so okay, count is equal to X. We've got our number. So for every digit in the number, we can kind of just do this like we did earlier, which is we can say, hey, evens is equal to 0, 2, 4, 6, 8, and say, hey, if digit in evens count plus equals 1. All right, so that's basically the way to do it if you convert it into a string and you want to iterate through everything like one at a time. This is useful if you're if you want to try that approach, but technically it's not as efficient, but really we're not yet in a class that really we really care about efficiency too much. So what is the other approach? The other approach is to go through and the digits one by one and basically go through and do some math operations. So what we're going to do is we're going to say while x is greater than 0. So in other words, while we're going to do this as long as x is more than 0, because we're going to be modifying x as we do this. Sometimes this is the hardest part to figure out. I know this part because I've done this kind of operation so often, but that's okay. But the idea here of how to do this, how to check digits one at a time using math, is what I'm going to do is I'm going to get the very last digit of this. The last digit of x is equal to, if I want to just get the last digit of like 7,583, if I want to get this 3 to check it, how do I do that, mathematically speaking? And the answer is you can't really do it with any of the normal math. You can't do it with add, you can't do it with subtract, or divide, or multiply. Can't really do that with a single operation. What we can use is, with a single operation, is modulo, because that gives us the remainder. Specifically, if I modulo by 10, if I modulo any number by 10, that will give me the last digit of that number. Because what is that saying? It's the remainder after I divide by 10. If I divide by 10, right? If I divide 7,583 by 10, this would be the quotient. Okay, and then the 3 would be the remainder. So dividing by 10 has that kind of, it's got a nice useful trick there. So so last digit of x is equal to x mod 10. And now I can ask myself the question about it being divisible by 2. If last digit of x, if I divide that by 2 and I don't get and I have a remainder of 0. So if, in other words, if x is cleanly if the last digit of x is cleanly divisible by 2, then that digit is a even number, right? 2 is cleanly divisible by 2, no remainders. 2 divided by 2. 4 has no remainder. 6 divided by 2 has no remainder, and so on and so forth. So if that last digit is divisible by 2, count is equal to count plus 1. We increment count. Otherwise, we just don't do anything else. Now, if I keep doing this, x doesn't change. So this gives me what's called an infinite loop, meaning it would never end. So now what I have to do is I have to get rid of this. I have to completely destroy that. So get rid of that number because we just used it. We don't need it anymore. I want to check this thing now. I want to check 8. And there are mathematical operations that I could just do to continue on to get to here, but honestly, that's a pain. So it's just easier if I just kind of get rid of that. And the way I get rid of that is I say that I can get everything, everything but last digit. You can give it a much shorter name, but I'm trying to make it easier for when you review your notes. Okay. Everything but last digit is equal to x divided by, and note that I did integer division there. If I do regular division gives me a decimal point, right? Integer division says, yeah, I'm just going to give you the quotient, the straight up quotient that without any floating points or any remainder or something. So for example, going into here, into our, so 783 and whatever, integer division by 10 gives me 7,839 gives me, divide by 10 gives me 783. Okay, so this gives us everything but the last digit. And then we can say X is equal to everything but the last digit. By the way, this creating the everything but the last digit was a totally unnecessary step. I could have just said X is equal to X mod 10, X is equal to X divided by 10. But for note-taking purposes, again, or if you're reviewing this later, I want this code to be easy for you to read. There are pedagogical reasons sometimes for me to make dumb, silly and expanded code like this. Okay, but that is one way to do this, where we just keep getting the last number. And this is important if we want to kind of divide our numbers into multiple parts, which we're going to need to do for the next one, which is for something called Armstrong numbers. Now, this is specific for 3-digit Armstrong numbers. Armstrong numbers have different rules for them, but we can look that up on Wikipedia. They're kind of numbers that, mathematicians who have too much free time come up with. They're numbers that have special properties. Okay. Also known as a narcissistic number. Because it must love itself. Okay. So given number B base is a number that is the sum of its own digits raised to the power of the number of digits. So in other words, if we have so specifically for 3-digit numbers is what we do here, because I didn't want to try to generalize this out for an intro assignment. So 3-digit Armstrong numbers is an integer such that the sum of the cube of each digit is equal to the whole number. So in other words, 370 and 371 are Armstrong numbers, because if you take 3, 7, and 1, and you cube each of if you take 371, cube each of the digits, 3, 7, 1, so 3 cubed, 7 cubed, and 1, if you add that together, you'll get 371. Same thing with 370. If you take 3 cubed plus 7 cubed plus 0 cubed, you add them together, you get 370. Again, they're narcissistic because it's all about themselves. They're Armstrong numbers. So write a function given integer as a parameter returns whether or not a number is a 3-digit Armstrong number. So what I like to do for here is when we're working on creating and we have the return count down here. So that's awesome. Almost forgot. I was worried I'd forgotten about that. So def Armstrong. I'm going to call this one is Armstrong. Okay. And this will be a problem for you. I'll start it out for you as normal. And then I will, and then I'll give it to you to do. Right. So this one, you're returning true or false. So basically what we want to know is we want to get the digits of these individual. So we want to get the ones value is equal to something, the tens, the value, and the huns and the 100 values, right? The ones place, the tens place, and the hundreds place, because we've got 3 digits, right? So you're going to have the 1, the tens, and the hundreds, right? And then what we want to do is we want to ask a question, which is that if this cubed plus this cubed plus this cubed is equal to the original number, then awesome. Now we don't need a loop to go through this one. You can use some math, or you could use some string conversion operations that, you could turn it into a string and do some operations there, which I feel is like cheating, but honestly, again, if it gets the job done, it gets the job done. And then either it's going to return true or false. So I want you to take a couple minutes to work on this one, and then I'll show you how to do this one and then the last one. Is there a question?
Do we use, the way you did was, divide by 10?
I mean, you can, but you can also just explicitly get the values by doing some interesting math, by using a good, clever combination of dividing by 10 and modding by 10 where needed. Remember, your common operations, divide by 10 to remove something, to remove the last digit, mod 10 to get the last digit. If I divided by 100, by the way, in the case of a 3-digit number, that would get me the first digit. So keep that in mind. Okay, just give me a second. I have to deal with something. All right. So let's go ahead and see how to do this one. So this one, we can just do some mathematical operations. I will get, if I do x mod 10, that gives me the one place, right? So if I have, annotate 1, 2, 3, this value is x mod 10. This value in a 3-digit number, I could get by doing x divided by 100. 100th place is not too bad to get. X. Okay. What about for this? This part is probably the most annoying, which is this guy, because I can't just do it in one clean operation. What I can do is I can throw away the last digit and then mod by 10. So I can do that again by erase here. Oops. X divide by 10, throw away the last digit, and then mod by 10 to get this new last digit. Okay. Divide by 10, and then mod by 10. Okay. Now, with regards to this, let me just check, because with working in multiple language, I always have to double check certain things. If I take something in qubit, it gives me an integer if it's originally an integer. So I don't have to worry about converting numbers. So now I can ask, I can just simply do, hey, if ones cubed plus tens cubed plus 100 cubed, if that is equal to x, return true, else return false. Lowercase in other languages, which always gets me. So now my fingers never know what to do for that. Is Armstrong 732? That should be false. And then 731 should get me a true. Now, one optimization we can make to this is that we're saying if this is true, if this expression is true, return true. If this expression is false, return false. One kind of optimization that can be done here is I can just do away with this if statement as a result and just simply return the value of this expression directly. Return, right? This is a Boolean expression. If this evaluates to true, we've returned true. Otherwise, we'll be returning false. All right, so now with 13 minutes left, let me take care of the last one. Okay, the last one is a problem from Savage's, Professor Savage's Java textbook. So this one is basically trying to say, hey, we've got a puzzle here, and we're trying to find a 4-digit number. 4-digit number where these following things are true. All 4 digits are different. The digit in the thousands place is 3 times the digits in the tens place. The number is odd, and the sum of said digits is 27. So what we're going to do that is, first things first, I will copy these things over here. Now this one is not one where we have to return something. We're just trying to figure out what the value is, and we can print it. So what we're going to do here is we will look for a number where this is true. Make sense? Okay. So, so what we need to do is that we need to, this is a bit, basically what we need to do is that we're looking for a 4-digit number. So we need to test every 4-digit number to see if it matches this, right? So best way to do that is to write a for loop that says, hey, for number in range. So what is our range? Our range is 1,000 to 10,000. That would give us, or specifically that starts at 1,000, goes up to, but does not include 9,999. Now, one of the rules says that all the numbers, that the number has to be odd. We can take care of this right here without having to deal about it with any if statements by changing how we do our for loop. Specifically, what we'll do is that we'll start at 1001, right? Which is the first valid number because that's the first that's the first 4-digit odd number, right? Go to 10,000. Right? And now what we'll do is that I'll add the third condition to the range statement, which says go up by 2s. Make sense? Okay. So now we have to deal with these conditions, which relies on us figuring out how to get all those independent digits. Now, we kind of already figured out, now we're dealing with a 4-digit number, so we have to kind of re-attack this problem. Tens, hundreds, and then thou is equal to something else. All right. So what we'll do here is let's go ahead and see if this still works for us. So let's go with let's see if these still work for 4-digit numbers. And spoiler, some of them will, some of them won't. So 1, 2, 3, 4. All right. So let's look at if we can get the ones place. Does this, if I do this number mod 10, does that give me the ones place? And right, does this number mod 10 give me the ones place? And the answer is 1, 2, 3, 4 mod 10. If we divide by 10, and ask for what the remainder is, we'll get 4. So this still works. The tens place. Okay, the tens place now says, hey, I want to do this number divide by 10, which got rid of this, and then mod by 10 to get the last digit of that number. So the tens place also works because it will get that value. However, the hundreds place now, right? If I do x divided by 100, integer division, that gives me 12, right? Okay, but I can still work with that. So how do I get the last digit of 12? I just mod by 10. Make sense? So, right? And now for the thousands place, that's fairly straightforward. I'll just divide by 1,000, right? 1,000 using integer division, right? If I divide 5,000 by 1,000, I'll get 5. Okay. So that gives me all the values there. Okay. Now the number is. So now I have to check if all the digits are different. And if all the digits are different, and if the sum of the digits is equal to 27. So, oh, and if this equation holds. So for the first one, all the digits being different, there is an easy way to do that, but we don't really learn about that until the end of the semester. Let me go ahead and just show it to you. The easy way to tell if a bunch of things are different, if I want to know if 4 things are different, then I'll just simply say if len set make a list with the ones, the tens, the huns, and the thou. And if I say if that is equal to 4, if that's equal to 4, then they're all different. What in the world did I just do there? Well, I took this list, I made a list out of all our values, and then I threw it into a set. The set is like a mathematical set. In fact, it's explicitly like it. And in mathematical sets, you can't have duplicates. So it would reject any duplicates we have. And then if there were less than 4 items in it, then there would have been a duplicate somewhere. So they wouldn't have all been different. Unfortunately, we did not learn about sets yet. And just throwing it here at that and saying, here's the magic, kids. You know, that wouldn't be very fun or fair. So the way to do this, annoyingly, is just simply to check if ones equals 10, sorry, if 1 is not equal to the tens place, and 1's not equal to the hund, and 1's not equal to the thou, right? And so on. So I've checked those. And 10's not equal to hund. We don't have to check 10's against 1's because we've already checked 1's against 10's, and that's reflexive, you know. And 10's not equal to thou, and hund not equal to thou. That's every possible pairing right there. Okay, bit long, but that's every possible pairing. Okay. Now, what we got here is if they're all different, let's check if the digit in the thousands place is 3 times the digit in the tens place. So if thou is equal to 3 times the digit in the tens place. Make sense? That one was fairly easy. And now if the sum of the digits is 27, if 1's plus 10's plus hund plus thou equals 27, then we found our value. So we'll go ahead and print it out. And we'll keep this as a print rather than return in case there are multiple values. And I'll just go ahead and call it right here. Name error, X is not defined. Oh, right. I didn't call it X, I called it number over here. Right? And the answer is 900,9837. So if we check that by I, it's definitely an odd number. All the numbers are all the digits are different. This number is the thousands place is 3 times the digit in the the digit in the thousands place is 3 times the digit in the tens place. And then if we add them together, we get 10, and then we get 17, which is 27. So that fits. Okay. So to turn in this assignment, what you're gonna do, sorry, to turn this in to get credit, just turn in what you have. If it doesn't work or not 100% correct, that's okay. I'm mainly just checking, did you participate? Did you follow along and did you give an honest try at the problems, right? And then I will go around eventually and check that and check who often gave you the points for this one. This one was worth 30 points of in-class assignment credit, which is not a bad amount. But that's what we have for today on, yes. Yeah. I don't have to put a number in that because this doesn't take a number because it's just simply running through, operations. Yeah, I made the mistake of copying and pasting there. I'm not immune to making silly errors. In fact, I make silly errors all the time. The difference between me making a silly error and you making a silly error is that I made that silly error a lot, like a lot. Not only have I made that error like a lot, okay, I've seen you make you and your fellow students make that error a lot. So I'm very good at finding out those errors and knowing why they occur, which is why I'll be able to fix, if I see an error, I can fix it like that. The only way you ever get better at coding is by messing up a lot. All right. All right. I'm going to go ahead and stop the recording.